Welcome back, everyone. What an intense day today. So far, we've talked about new digital solutions to facilitate the local presence and feasibility of nuclear reactors. And we've addressed the topic of international collaboration when it comes to supply chain. Now, let's get to the construction side of it all. The energy produced by the current reactors represents about 10% of the world's electricity, which is equivalent to 380 gigawatts of power. This figure could double or even triple by 2050. With the renaissance of nuclear power, large programs are being launched or relaunched around the world. And this all starts with France. This panel will discuss how to deliver nuclear new build programs successfully, focusing on challenges met during the construction phase and how to address them. Please join me at giving a warm welcome to the ASSYSTEM Marketing and Communications Director at GIFE, Anne-Charlotte Dagorne.
Hello everyone, welcome to Paris and to the WNE. My name is Anne-Charlotte Dagorne and it is my great pleasure to be with you all to moderate the ASSYSTEM keynote on how to deliver nuclear new build programs successfully. It is obviously a very broad topic, so today we will focus specifically on the construction phase. So let's jump right into it. Please join me in welcoming our guests, our chair Stéphane Barbier, ASSYSTEM Deputy CEO, Damien Bilbao, Equipment Director for EPR2 from EDF, Jean-Luc Alexandre, CEO of NAREA, Chen Mingguo, Deputy General Manager from China Nuclear Industry Washing, and Jacques Besnénou, Chief Commercial Officer from Westinghouse. Welcome to all of you, gentlemen. So, first thing first, let me give the floor to our chair, Stéphane Barbier, for his opening remarks.
Hello everybody. Good afternoon. To introduce the topic, the roundtable of today, which is all about how can we deliver new build program on time. Just a first remark, which is that. And you can see it in the exhibition for the 2 last days, yesterday and today. It's pretty obvious that nuclear comes at the forefront of the projects envisaged by a significant number of countries to fight the climate change and to recover energy supply sovereignty. Out of the 12 countries in which ASSYSTEM is involved to go along with the government and the utilities to develop the nuclear projects, 8 of them are newcomers in new build program. In nuclear industry. It's a good news for our industry, of course, definitely. But in the meantime, it raises the obligation we have to deliver the program in time, and such at least for 2 reasons. The first one is that if everybody is keen to develop new nuclear electricity capabilities, it's good for them to fix their situation between the years 2030 and 2040. So not in 20 or 25 years from now, in about 10 years from now. We all know, I guess, in that room, what is the normal duration, the usual duration of a new build project. About 100 months, something like that, when we are at the best level. Now, I'm sure that our Chinese friends will explain how they can do better than that. So we have, first of all, to do it on time, and then maybe even to speed up a bit the way we are able to construct, to erect new build programs. Second reason, that the main hurdle we have now to get into new nuclear programs is the funding of the programs. And funding of the programs is mainly depending upon 2 things: the risk of the program And second, the duration of the program, meaning that the faster we are able to deliver, the cheaper the project will be and the most affordable the electricity price will be. Then it means that, and we are here to exchange the different opinions from different nuclear industry filière and different nuclear families. I mean, high power reactors and small power reactors, to see how it is possible to tackle that challenge we have, all of us, to reduce the time for construction of new build programs.
Thank you, Stéphane. I would now like to leave the floor to Jean-Luc for his opening remarks.
Thank you very much. So we are developing, as you said, when you talk about construction of new build program, we went for very small units because we believe that building small units in an industrial top-end industrial environment will be a key for reducing the time to market. So we are developing new micro generator of 40 megawatt, very small one, tiny one, in a 40-foot container. So you see it's fully industrialized, no civil work on site, so it means a lot of advantages. So this is the new thing, the new thinking of the nuclear, thinking of not site construction, but plant construction. And then it's easier because you will increase the reliability of the construction. You know, the alias of construction are always very high, whereas in the plant, you manage almost everything. But the other thing is that you get a lot of flexibility. And you can increase the demand, you can increase the output of the generators, you can put them in parallel in series as much as you want, and so you can follow the load from the customer. It's a new way of thinking the things, a new way of building the business model.
Thank you, Jean-Luc. Damien?
Thank you. Alors, for us, and especially for EDF at EPR2, we are clearly at the other side of the output power. EPR2 is a series of 6 nuclear power plants that will be built in France in the next 15 years, and with a power around 1,600 megawatts. But the challenge is exactly the same as the others. It's to focus on constructability, and constructability is perhaps the main focus of interest for us. And in fact, it goes back to the roots of EPR2 project. Why? Because if I want to summarize EPR2 in a few words, EPR2 is just, sorry for my colleagues, an EPR that was redesigned to have a better constructability and taking into account the lesson learned of the 6 first EPRs that either are already built or under construction.
Thank you very much. Jacques?
Does it work? Yeah. Yes, good afternoon. It's such great feeling to be here. I've been in nuclear for all my life, and I've seen up and down, and I could see now a big, I don't want to call it renaissance because I'm superstitious. I was there the first time. So I would say a great nuclear comeback, and to see how so many people, new companies coming, the new generation actually, we're attracting new people. So, it's very, it makes my heart very feel, I feel really good today. So thanks for being here. Just about Westinghouse, we started a long time ago, as you know. Actually, I would say we gave to the world the nuclear energy as we see it now today. I mean, there was a huge technology transfer to France, and now we are talking about new reactors. Our new reactor is called the AP1000. This is a flagship. It means advanced passive safety. We have 4 in operation already in China, 6 under construction. So I'm turning to my friend here. 1 in operation in the US and 1 coming very, very soon in operation next year. So this is the beginning of a new chapter for nuclear industry as a whole, and looking forward to it. And during the question, I will tell you what we need to be able to build on time and on budget, hopefully. Thank you.
Thank you, Jacques. Before I leave the floor to Chen Mingguo, just know that by scanning the QR code, you can have live translation via your phone. So, Mr. Chen Mingguo, for your opening remarks, please.
非常感谢主持人的邀请啊，这个今天参加这个会，我这个也非常高兴。我觉得我也是从事核电建造，我是来自中核集团的，主要是从事核电建造这方面，我已经也是干了这个20多年了。我觉得其实核电建造技术啊，可能刚才主持人也讲，就是我们中国可能建得非常快，质量呢也非常好。我觉得呢，可能每一个国家也有每一个国家的国情不一样。我觉得我们这个同行啊，包括我们的法国，包括美国，其实我觉得他们也都干得非常不错。这可能有很多，可能更多的我们要相互学习、相互借鉴，可能能够把我们的这个核电啊，能够高质量的完成。我就先说这点，谢谢。
Thank you very much. So I would now like to ask a first question to you, Jean-Luc. You worked in different industries in your career on the construction of complex infra projects in the water, in the transportation sectors. What lessons can be learned from these sectors when it comes to construction management?
Thank you very much. There is a major difference when you look at the market. When we go for nuclear today, we think about public markets, huge utilities. When you come to other sectors, you see that there has been a shift to the private market, meaning talking to the direct user, which is the industry. So we learned a lot from the water sector and the transportation sector. First, that there are different markets, and the private market now is moving very fast. And second, the value chain is totally different. The industrial market is waiting for a totally integrated value chain, meaning that they need a service. They don't need anymore to buy an asset. They don't need to buy an infrastructure. They want the service. So let's use this. Let's try to use this to nuclear, serving the energy, so delivering the energy that can be heat or electricity directly for the industrial market, meaning for industrial plants. And this is a huge shift for nuclear, because it means that we would be able to put a micro generator on the premises of the industrial plant, not necessarily connected to the grid. You can be connected, but you cannot be connected sometimes. So it means a lot of different things. And the last one is that you need to put a lot of innovation into the system. And once again, if you have a totally integrated value chain, from the design to the construction to the operation, you can integrate innovation because the operator will take the risk of the innovation, which is not the case when you separate the different phases between the designer, the manufacturer, the builder, and the operator.
Thank you. That brings us to the key topic of our panel today. What are the key success factors to build nuclear new build programs on time and on budget? Jacques, maybe to start?
Yeah, sure. Thank you so much. I think the key to a successful program, successful and to be able to build on time and budget, is to have a fixed design. Don't start construction or don't start anything, maybe ordering material before you have a fixed design. It was a mistake we made in the past. We should not do it again. Number two, we need a fixed bill of material. We need to know exactly how the supply chain is made of and where all the components are coming from. The issue for nuclear power is that we're suffering what we call stop and go. We build, take the example of France, we build for 20 years, extremely successfully, and we stop for 10 to 15 years. Same in the US, same everywhere. So now we're starting again. We need to be able to continue to keep the momentum.
So thank you, Jacques. I would now like to hear Mr. Chen Mingguo and your expertise and your experience from the projects you worked on in China. According to you, what are the key success factors to build on time?
Good. 这个我刚才也给大家分享了。首先，我觉得啊，就是我们每一个国家、每一个公司干核电站，可能都会有一些不同的方法和不同的他们的长处。我这边呢，我想给我们在座的同行，分享我们3点， 第一点呢，就是这个我们干核电那边是建筑和安装和一体化的，就是我们的 erection 的 civil 是一体化。这样的话呢，可以保证我们的就是土建和安装能够深度交叉、深度融合在一起，包括我们的一些资源，包括我们的一些零件设施，包括我们的进度计划，包括我们的这个就是在这个施工过程中的协调，这2家单位，当然我刚才也讲了，这个可能是每一个国家不一样。在我们中国核建就是安装和土建属于一个股份公司，这样的话呢，就是我们的建安一体化的协调，我觉得这是非常容易的。这点呢，可能是我觉得是我给大家分享的第一个。第二个呢，就是关于在我们中国核电啊，就是在我们核电厂附近，我们有很多大型的预制工厂，无论是我们的钢结构也好，还是我们的一些管道预制也好，就是我们有大型的预制工厂。另外也给大家报告一个好消息，就是我们现在我们法国的一些公司也在接触我们公司，他们也希望呢，就是在中国看能不能给他们供应一些这个预制构件，包括管道。现在正在接触，这是一个好消息。我们的也是预制工厂呢，也在靠海边，可以输送到我们这个非常方便的输送到世界各地。最后一个呢，就是关于我们的先进建造技术这块儿，就是我们这个在核电建造过程中啊，也使用了大量的先进建造技术，比如说我们的一些我们现在一些很多的用的自动焊接技术，还有 beam 技术的。和我们模块化的深度融合，另外就包括我们刚才西屋，我们也讲了啊，我们西屋做 AP1000，我们在中国 AP1000应该已经是在投运了，做的这个模块化这块啊，应该是做的非常不错。这个我觉得这个也是非常好的一种设计理念和方法。另外呢，就包括我们现在也在做一些数字化的一些技术，我觉得这些都是值得我们会长给大家分享。好，谢谢。
Thank you very much. Now turning to France with you, Damien, focusing on the EPR2 programs, what are the key elements you would like to share with us to successfully build these future reactors?
Thank you all. I will repeat some of the good ideas that others shares, because of course it's the same industry. So for us, there is 4 main points of constructability. The first one is standardization. It's to have fewer types of equipment, fewer type of doors, pipes, valves, pumps. And in UPR2, we work on catalog, and engineers can only take these elements from the catalogs. So it's the first point, and it helps to simplify the works. The second point is to take into account constructability into the design. So we worked with civil works companies to have a design that is simplified, and also modularity where can be where it's possible. The third point is is very important for us. It's replication, because of course when you do for us at least 6 of them, we will learn from the first to the second, and for the second site from the third site. It's very important, because what we did the last decades, it's to do one and stop, and of course we know that it didn't work very well. And the last point, as this was said just before, like in China, it's prefabrication. So we are aiming at maximizing prefabrication outside the different constructing sites, in order to minimize the weldings that are done on site. And we are aiming to reduce by something by half the number of welding done on site. Thank you.
Thank you. Talking about prefabrication, I think, Jacques, it's also something you are implementing on the AP1000, right?
No, thank you so much. Yes, that's great. That's the key, actually, element of the AP1000 is that it's a very modular reactor. We have a technical module, piping, and so on. But also we have I would say the containment. The containment is modular, actually. So everything is like a Lego. It's a Lego game. So most of the main components of the AP1000 are actually made off-site, so we can work in parallel. So this is something we have mastered with our Chinese colleagues, but also in the US, and that we are going to reuse, of course, in Europe. So modularity is key.
Thanks, Stéphane. You wanted to add something?
Yeah, we of course, obviously, all talk about nuclear industry, but frankly speaking, I come from automotive industry. Jean-Luc is coming from transportation and water industry. In fact, nuclear construction is not so different than construction of some other infrastructure projects. I mean, the rules to be on time are always the same. I mean, some have been already said. The first one is, of course, to have a stabilized design, as a modification during construction costs 10 times what it cost during design. So start to construct when you have the design. The second point is that if you want to be on time, just de-risk the critical path of the construction schedule. And to de-risk the critical path of the construction schedule, the best way is not to do everything on site, but to prefab and to have to prefab as much thing as possible to spend the shorter time possible on site. So what we are discussing here is just, the learning curve of any other industry or infrastructure project. So it's not rocket science, in fact. So I would be disappointed if everybody was leaving the room thinking that in nuclear there is a specific problem. In nuclear there are no specific problem. Those are project traditional issues.
Thank you, Stéphane. Mr. Chen, you mentioned it a little bit in your previous answer, but could you tell us a bit more about the advancement of factory prefabrication in China for nuclear construction?
好的，这个中国因为中国啊，还给大家介绍一下，中国也是因为近40年嘛，我们中国是近40年一直核电是没有在停，就一直在建核电，所以说在核电的就是这个预制件方面呢，应该说还是很有一些经验给大家分享。其实正如刚才各位讲的一样，就是作为预制件啊，就是作为我们现在核电的预制件，我们在中国有一句话，按中国话就是说呢，怎么说呢，就能磨尽磨，就是应磨尽磨，就是能够做模块化的就一定要做模块化。这个应磨尽磨，就是你考虑这个模块化应该要做的，就一定要做成模块化。这样就刚才我们介绍的，也减少了现场的这个工作量，也减少了现场的风险，把这个车间预制呢，可能这个品质控制也好，安全控制也好，应该能做得更好。我们国内啊，就是我们中国综合集团啊，在国内的各个地方，就是我刚才也给大家介绍了，就是在各个核电厂的附近，也有很多预制工厂。另外呢，在我们的江苏省，就是在江苏省，包括广东省，还有一些比较大型的这个叫什么预制工厂，就专门生产钢结构，然后专门进行管道预制的工作。这个呢，前段时间呢，我们有些法国朋友也到我们的工厂进行了交流和考察，他们也是对我们的预制工厂的这工作呢，还是比较肯定。就是总的说来呢，就是我们大的原则还是，跟这个从施工角度啊，当然也是要跟设计可能结合在一起，要想办法把我们能做成模块化的，能在工厂预制的全部做成预制。这样的话，我们到现场，这个整个进度、这个质量、工期、安全都好控制。我就再给大家分享一点，谢谢。
Thank you very much. So obviously we can't talk about prefabrication and modularity without mentioning your project, Jean-Luc. Could you tell us more about your XSMR project, modularity, and why this is key to guarantee the construction time of these small reactors?
Yes, so NARIA is not only an XSMR, it's a XAMR, which means it's a fourth generation of nuclear, so a little bit different, because we are on a molten salt fast neutron fission. Of course, the essence is that we are very small, because our microgenerator fits into a 40-foot container. When you go small, you know that you will design not in tens of units, but in thousands of units. We prepare ourselves to be able to manufacture thousands of reactors for the next 30 years. So when you make the design, you consider that each component will be manufactured in thousands of units. So you do not design it the same way. You spend a lot of time to try to optimize the way to manufacture it. But then the beauty is that having a small unit or small items or small components means you can innovate a lot, and using new materials such as ceramics, for example, or additive fabrication, 3D printing. You cannot do for huge components, you can do for smaller ones. And of course, when you go for 3D printing, for example, you can reduce significantly the time for construction. So this leads to imagine that you can produce a gigafactory able of delivering one container or one microgenerator per day. It's feasible. When we talk about automotive industry, aerospace, water industry, transportation industry, we are already on those numbers. We did that in the past. So, as Stéphane said, we have overcome those problems. And the beauty is that today, with nuclear, we can totally rethink the way we will construct, so that we build everything in a plant. So we will increase reliability, we will increase the non-quality, and you have no alias once again from the site. Civil engineering, civil works are the worst conditions to manufacture, because you depend on a lot of things on which you have no impact at all. So you just need to be prepared, and you have a risk management higher. In a plant, it's much more easier.
Thank you, Jean-Luc. Another important element that can impact the construction time is linked to more logistical aspects, I would say, such as accessing the site or the work schedules in place. Stéphane, ASSYSTEM works on many programs around the globe. Could you tell us more about the differences that you've noticed regarding this?
No, it's true that as soon as we talk about prefab, about having a modular, I would say, functions that has been pre-assembled in factories, then it's even strengthening the issues you can have with logistics. I mean that to be able to prefab, you need land around the site, close to the site, to be able to do so. And then you need to have the roads, the paths, the accesses that allow to carry out all those prefab items on site. Then as well, and it's maybe more an issue we realize in Europe than in other countries, as we work in the Middle East on Baraka construction site with the Koreans, or in Akuyu projects on the Russian nuclear technology. Of course, I mean, a specific attention is put as well on the ability to have a productive manpower, meaning to have a swift and seamless access to the site of the different shifts to be able to make the construction work. Because once we have talked about technology, I mean design and modularity, all the stuff, I mean at the final end, anyhow, those are people that will make the job. If we are not able to work, maybe not in Europe 7 days a week, but at least 5 to 6 days a week. If we are not able to work at least 2 shifts, maybe 3 shifts, but at least 2 shifts, with a productivity of 90%, then we will be late. And it's not only a labor law issue, it's as well the ability we have to make accessible the site for the people fast. we can see, even in there, and maybe Damien could give some words about it, but when you just consider the difference between Flamanville, FA3, and HPC, a lot of progress has been done in that regard. I mean, I test myself, I mean, about 2 hours to access FA3 if you don't have a badge, about 10 minutes to access HPC site if you don't have a badge. So it makes, at the final end, a huge difference in the pace of construction.
Damien, did you want to add something on this?
Yes, but I might repeat exactly what you said, because we learned a lot from the HPC logistics. They have done a real great job about parking lots, shuttles, even secured shuttle that can go directly through the gates of the site. They do the security check on the parking lot and not at the gate of the site. They have done a lot of great things that we will implement in Upper 2, such as transportation. I'll talk about shuttle, access with a large access point to the site for people on foot, for trucks. So it's there is also a something very important. It's logistic service. It's not for the operators to go to the warehouse and to wait that the tools or equipment will be given to them, but that overall, all the site must be organized to maximize the tool times of the operators.
Thank you, Damien. I think when talking about efficiency, about productivity, we must also discuss the impact of digital technologies. Jean-Luc, what is at stake here, and can you explain how your project is taking advantage of digital?
Everything is starting with digital today. So if you want to go fast, and especially on industrial project, you need to start on a complex project with a digital twin, because you need one unique digital platform to be sure that all your people working on the project will be working on the same project, which is not always the case on a regular project, on the construction one. So you need to be sure that you will have the right version of each drawing, that each person making a modification on a drawing or on a design is qualified to do it. You can check this out with the digital. And then you have what we call the digital continuity of data, which is key, that goes from the design to the manufacturing to the industry. So with the same platform, you can go also on the layout of your industries, of your plant, that will be able to make it. And with the same platform, once again, you will be able to do the training. So the digital tools are the heart of any complex project today, but especially for small units on a high series.
Thank you, Jean-Luc. So digital is indeed a strategic lever to deliver nuclear new build program successfully. Another strategic point is quality. Damien, your division was created to work on that topic. Can you tell us why and what is being implemented at your level?
Yeah, I'm personally convinced that the quality of equipment that are shipped to the site are directly linked with the quality of constructions. Because if you have quality problems in factories, it takes some time to correct it. But if you discover the quality problem on construction site, it will take 10 times, 20 times. So one key point to constructability and quick constructability, it's to have the right equipments with the expected qualities at the right time. I think it's completely clean. So we have to be sure that someone, a team, oversees that in the supplier factories, on the prefab sites, but also during all the logistics chain, during transportation and in the warehouse, because we can have quality problems in a warehouse. So my direction was specifically created for that, in order to tackle all these subjects and to relieve that charge that of the operators in the construction site, and to enable them to focus on their main task and not on what happened before.
Thank you very much. Jacques, I think there was another topic you wanted to mention that was really important for you, is the importance of collaboration in that context.
No, thank you so much. I really believe that we are not enough. We have not enough suppliers, not enough people. We need to train. We don't have the workforce needed to do all the projects. If you put all the projects together in Europe, it's going to employ a lot of people. So we need to. So my message here is that we need to work together. We need to share the supply chain. We need to educate the supply chain in Europe, in particular, and we need to do it in a collaboration. I have a word that I think I invented a long time ago. I don't have any competitors. I have only competimates. Sometimes we compete, sometimes we mate, we say, huh? And so we should do it together. And my last message really today is that we need to do it in a way that it's safe, because one mistake anywhere is going to affect all of us. So we are open, we're willing to share our lessons learned, we want to work with all of you. We need to make it safe, on time and on budget. Thank you.
Thank you, Jacques. So that brings us to the end of our keynote. I would like to leave the final word to our chair, Stéphane.
Yes, just elaborating on what you say, we face, after the Second World War, a period of time where we shared a lot about nuclear industry. I mean, sharing the knowledge, and in France, we got the knowledge from the US, as you mentioned at the very beginning of the panel session. We went through a period of time where everybody seems to be in competition because the projects were more rare than the offer. Now we enter in a different period of time where, in fact, probably nobody is able to deliver alone on its own with his own supply chain everywhere in the world. It will not fly anyway. So yes, we enter in a period of time where we have to share the supply chain, and there are already some initiatives here and there, especially in Europe, to do so. Not talking about the collaboration we have already with Russia, with China, and with other industries. But I would say that on top of that, the nuclear industry worldwide in each country is very focused on itself by tradition. I mean, there is a lot of confidentiality around that. I mean, everybody is focusing on this intellectual property and so on. Okay, that's a fact, but it will be difficult to be successful, not first of all to put together the supply chain, and then as well not to consider the experiences that has been successful in the different programs around the world, and then it draws to have a change in the behavior of the different nuclear industry in each country to start to open to what is going on abroad, and not only to focus on its own problems or successes. So I think that maybe it's positive for there are lots of young people in the room, which is great, which is a good sign. It means as well that probably, we will have to work with different cultures and different people in the coming years, which is good. Thank you. Thank you to all of you.
Thank you, Stéphane, and thank you to all of you. Please join me in thanking our speakers for their insightful comments, and thank you to all of you to be with us today.